YouTube says I'm live, so let's hope people can hear me. So welcome everyone. Let me know in chat if you can hear me. Let me know in chat if you can't, which is more difficult, but it's one of the two. All right, let's switch to the layout for today so you can see me as well. So hi everyone, welcome. So today we will be talking about large language models, and I've actually gotten quite interested in them. Like originally when they came out, I thought it was just a big fad, but it's interesting, and I've been doing some experimenting with it, and I like them a lot. So I've set up some on Windows, I've set up some on my computer at work, which is a Linux machine. So today I just wanted to go through all of the steps that you have to take to set up a local large language model on Windows, and then make sure that you use things like CUDA so that you can actually benefit from your CPU. So no message in chat, so I actually hope that I'm audible, but we'll have to see if that's the case. Otherwise, this is going to be a very professional stream. Anyway, with that out of the way, the question, of course, is what are we going to build today? So I thought it would be nice to build a very basic program. So something which takes as an input a little piece of text and then Snoop Doggifies it. So that's what we're going to end up with today. I call it my Snoop Dogg Inator from Phineas and Ferb. But of course, before we get there, we have to take a whole bunch of steps. So first step is to kind of set up our environment by installing Python, pip. Then we have to install Visual Studio. I'm not going to install Visual Studio for you guys. I'm actually not going to install any of the tools. I'm just going to show you how to do it. And that is because I was a little bit scared that I would break my own environment while doing it, because you need a lot of very specific versions for the thing to work. So I thought this morning I can uninstall everything and then show you guys how to set it up from scratch. But I thought that that would be too much work, and not just too much work, but it would be difficult as well. But anyway, so after setting up Python, setting up pip, doing Visual Studio, you'll have to download and install CUDA. So this means that if you want to use a GPU, you have to use an NVIDIA GPU. There are other packages which will allow you to do it on AMD GPUs or other GPUs. But since I have an NVIDIA GPU, I need to use CUDA if I want to use my GPU. That being said, even though you might not have an NVIDIA card or something else, then you could still set it up, right? You can still use your CPU. It will just be a lot slower. First comment in chat. Hi, Paolo. Miss you. Well, miss you guys too. That's why I'm actually streaming again. I've been having a very, very busy time getting set up at university and doing a lot of marking and all of these things. So I haven't really had time to prepare this. So when I was working on this for work, I thought, like, this is fun. I should do a stream about it. So that's why we're streaming today. All right, so we need all of these things installed, set up. So we're going to go through each of the steps in detail. So just go with me, install the software. If you run into any issues, then let me know in chat and we can help you set it up better. But once we have Python, Visual Studio, and CUDA set up, then the next thing that we need to do is install a whole bunch of Python packages. And some of these Python packages you need to compile from source. That's actually why we need Visual Studio. So that's going to be a bunch of command line typing. So on GitHub, I actually put all of the code that I was using to install the environment. And let me put a link in chat so that people know the GitHub. It's also in the description. But just to make sure that people know where to find it. So if you go to the repository, let me quickly show you guys the repository as well. It looks like this. So there is commands.txt. So these are all of the commands that we are going to run to set up the environment. Not all of them are commands, right? Because these first couple of them, they are not commands. They are just going to places to download stuff. I have all of the tabs open on the top, so we'll actually talk through those as well. But we need to install some of the packages for Python. We need to upgrade some stuff, and then we need to install CUDA supported versions of some packages. So that's what we're going to do today. After we've set up our whole environment, the next step is to create our own Python script. So our own Python script today is going to be a Snoop Dogg inator. So it's going to be a thing that takes text and turns it into Snoop Dogg, or how Snoop Dogg would have said it. And then I want to talk to you guys a little bit about next time, because I kind of want to have your input on some fun stuff that we want to do. If I have Linux, I need Visual Studio. No, if you have Linux, it's gonna be a whole different setup. It's gonna be very similar, but there's going to be some major differences, especially when it comes to CUDA and setting up your video card. So I will write that down as a suggestion for next time, to do the same guide, but then for Linux, because I wanted to do it for Windows, since from the comments that I get on my channel, I actually see that a lot of people are actually using Windows, but that's the reason why I chose Windows today. All right, so with all of this out of the way, let's get things set up. So the first thing that we need to get is on the list, and that is Python. But I wanted to talk a little bit about large language models as well, because we've been hearing a lot about ChatGPT and Google Bard and Perplexity AI, and like AIs are popping up all over the place, right? And people are using it to kind of write exams or things for them, and we've ran into a lot of issues in the last semester with students using AI, and that's kind of the dark side of AI, I would say, right? So every new technology comes with benefits and it comes with drawbacks, or challenges. Let's call it challenges. So large language models are not that new. It is just a type of machine learning model which has been used a lot already since like the 1990s. However, in the last couple of years, there have been some major advantages to using large language models. So some new innovations came in, like the multi-headed attention model. Some other innovations came in. One of them is actually big compute, right? The reason why we can do this now and not in the 1990s is because of the fact that we just have so much computational power at our disposal. So most of the computational power at our disposal is actually due to these massive GPU clusters. So if you think about these new NVIDIA video cards, these H100 or the A100s coming in, these are massive video cards which have like a massive amount of RAM on them. I wouldn't even say how much. It's probably in the order of almost a terabyte of RAM on a video card. But the thing about large language models is that they are geared towards doing natural language tasks. So I see a lot of papers coming out where they use large language models to do all kinds of things in biology. And you can train a large language model to understand kind of the language of proteins or the language of RNA. But what they really excel at is natural language tasks. So English, German, French. So they are really good at generating new text. We call that the generative ability of large language models. They are also pretty good at classification. So they are pretty good at determining if a text is English, French, or German. And they're also really good at translating from one language to the other language. And apparently they're really good at making text sound like Snoop Dogg, which is one of the things that amazed me as well. But these things are novel. right? So a lot of people are using them nowadays. They're using ChatGPT. They're using all of these kind of tools to help them write their thesis. But in the end, they are not knowledge-based tools. They don't know anything. They just predict based on your prompt, so based on what you type into them, what the next words are going to be. That is the whole trick, right? It just looks at the text that you gave it, and then based on that text, it will generate the most likely next word. So when I describe them, I always describe them as the mirror from Harry Potter, right? The mirror where you look into the mirror and it shows you what you desire most. This is exactly what a large language model is. It is a mirror, you give it a prompt, and then it tells you what you want to hear. So that is kind of my take on large language models. But they can do some amazing stuff. So without further ado, let's get you guys set up so you can have your own local large language model and you can do your own kind of coding and playing around with it, because it's really, really fun to play around with it. And I hope that we get some time by the end of the stream to play around with doing some fun stuff. All right, so the first thing that we need to get is Python, because large language models are more or less or almost Python exclusive. That's not entirely true. But Python is just a very useful shell around most of these large language model tools. So Python is a general purpose programming language. It's used a lot in bioinformatics. You can download it here, and I always install Python to Python 3. So one of the things that we have to be mindful of, and let me go back to here, is that we actually want to have a very specific version. We want to have Python 3.11.4 or 3.11.5. And this is because the field of large language models is changing so quickly, is that you just have to standardize on a certain version. So when you click download here, 3.11.5 should be fine, should be very similar to 3.11.4, the version that I have installed. But don't take the 3.12 pre-release version. It is slightly different, and packages might not be exactly the same. So do not help test Python 3.12. So the way that Python downloads work is you just download the executable by clicking the large button, and then once you've installed Python, you just go through the installer. So you just say next, 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 next. However, when it asks you where you want to install it, make sure that you install it into C:\Python 3. So not into the program files folder, and this is just so that you don't have any spaces in the path, so that we can very easily call it. So once you have that, then when we open up our command window, then in theory, when you type Python, and I hope this is readable, when you type Python ---- version, it should tell you that you have Python installed, and in my case I have 3.11.4. So just a heads up, don't install Python 12, install Python 3.11. Alright, so that's the first tool we need to get. So I hope people are currently like downloading Python and very, very quickly clicking next, 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 finished. So the reason why I'm not doing all of the install steps with you is because it takes a lot of bandwidth. If I look at my hard drive, just setting up a local large language model means that I'm using already like 15 gigabytes of hard drive space. So if I would have to download like 8 gigs while streaming, it's gonna break the stream. And large language models might actually break the stream because streaming takes a lot of video card memory as well. And when we start running the models, it might be that like the stream cuts out because of the fact that the large language model is starting to use all my video card. All right, but first things first, install Python. Python, very useful language. You probably already have it installed if you're watching my channel and doing something in the bioinformatics sphere, because that's generally what you use. So it's either R, Python, or C++, or something like that. All right, so the next thing that we want to get is the Visual Studio. So Visual Studio, we need that to compile the C++ code, which is used in Torch, so in PyTorch. Wow, cool. But I'm on a Linux machine. If you're on a Linux machine, the steps are not that different. The only thing that you have to be careful of is that you don't need Visual Studio, of course. So if you're on a Linux machine, then you have Python installed by default. Make sure that you have the correct version of Python. And you need, of course, the CUDA installation. So you need to have a video card, an NVIDIA card, which is able to run CUDA, or you need to have a really good CPU to be able to run the model on the CPU. But the code is not that different because the code that I wrote works under Linux and it also works under Windows. So again, there's a free version of Microsoft of this Visual Studio. So just get the free version. It is called the Visual Studio Community Edition. So if you go to the link here, again, it installs by default to here. And when you install it, because when you download it and then say install, make sure to add the Python development workload, and then add the native development tools option. So this is very critical. If you fail to install this, you have to deinstall Visual Studio completely, and then you have to reinstall it with the correct options. So the correct options as soon as you install it. So while I was installing it, I took a screenshot. So this is how the installer looks like. It tells you which workloads you want to install. So in this case, we click on the Python development workload, and then we have to add this Python native development tools. So make sure that you click this button and then here the second button, which is the Python native development tools. So these are part of Visual Studio. Don't start Visual Studio. We're not going to use Visual Studio for anything. Sahid says hi. Hi Sahid, and hi everyone else. So we're never going to open up Visual Studio. So I installed it. It takes around 3.5 gigabytes of space on my hard drive. Haven't opened it up yet because we're just going to use the Python tools and we're going to use these tools command line. There's no need to start up Visual Studio because when you start it up, it asks you if you want to register and you get a whole bunch of spam from Microsoft, which you don't want. So just download the Community Edition, which is the free edition, and then select the Python development option and make sure that you click Python native development tools. So if you're doing this too fast and you just forgot to click the native development tools, uninstall the whole thing and then reinstall it with the two correct options selected. All right, so start installing. It will take some time. This is, you probably have to reboot your PC like once or twice as well, but it's just the way that it is. But I wanted to go through all of the steps so that we can have the setup complete. So make sure to select these two options. All right, so the next thing is then to get the CUDA library. So the CUDA library is for NVIDIA graphic cards, and it is available on Windows. It's also available for Linux. And in this case, we're going to install it again to the default path. Because fortunately, when you install CUDA, it updates all of these settings. So that should be all fine. So the CUDA toolkit that I took, so it says here 12.2 update 1. And this again is very important that you select the correct version. Because if you click on the link here, it already goes to update 2. So let me show you guys that. So if you click on the link there, so then you already see that it's the CUDA toolkit 12.2 update 2 download. Again, it should work, but like I said, it's a very, very fast moving field. So as soon as you work with large language models, stuff that used to work today might not work tomorrow. So it's one of these things. But select the Windows version. Again, it's just an installer. Just say next, 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 finish, and wait for the thing to install. All right, so in theory, we should have everything set up now, right? We have Python, to install all of our Python packages and to compile the code that we're going to write. We have Visual Studio, which is a requirement for downloading or for compiling the C++ code, which is in PyTorch and which is in LlamaCPP. And we have NVIDIA, the CUDA toolkit for accessing our video card abilities. All right, so the next step is to open up the command prompt window and to start installing a whole bunch of Python packages. So the way that I generally install them is to install the latest version of the package, unless that doesn't work. Or what do I mean by that it doesn't work? I mean that when I run into issues later on. So let me go back to here, because besides the command.txt file, to make sure that we're all on the same version, I also dumped my version.txt file from Python. So here it lists all of the packages that I have installed in Python. So these are the ones that I need with the exact same version that I have. So if you run into any issues in Python and it tells you that this function call is different or this doesn't work, in many cases it's going to be a version difference. Fortunately, it's very easy in Python to install a different version of a package because you can just add the version number. So for example, if we think about like LlamaCPP, which is the one that we're going to use, I'm using an older version. It's 0.1.77. And of course, if you look at the natural language toolkit, I have 3.8.1. So any issues that you run into while coding, when you get a Python error saying that this function is wrongly called or the parameters to this function do not match, it is generally because a new version of a package was installed. And this is just one of these issues with having this fast-moving field. Like I said, we're explaining today how to use a certain type of model, and I saw that 4 days ago everyone switched to using a different type of model. So we'll get to that. However, I think that it's still a useful tool, and you can very quickly switch out to the different binary representation. It's just that I didn't have time to update stuff because I just came back from a concert/festival. So again, very fast moving field. Stuff that is in this video today might not be valid in like 4 weeks. It's definitely not going to be valid in 4 weeks, but that's how we work. All right, so what do we want to do next after installing Python, Visual Studio, and installing the CUDA toolkit? Well, we need to install a whole bunch of Python packages. And these packages we need to install either normally, or we need to make sure that they are compiled with the correct version of CUDA. All right, so click the Start button on your Windows machine, type CMD, and press Enter to open it, and then you end up with your command prompt. Generally, you won't be in C users Denny. This is just my own folder, but you will be in C users and then your username. So first things first, what are we going to do? Well, we're going to install NumPy and PyTorch. So NumPy is a package for multidimensional arrays because we're going to have to deal a lot with matrices, 3-dimensional matrices, 2-dimensional matrices. And PyTorch is a machine learning framework. So PyTorch needs to be installed with CUDA support. So it has a different command compared to things like NumPy, LangChain, and sentence transformers. But we're going to install these 3 packages. So the way that we do that, and I actually can show you guys how to do this. So let's just open up this one, right? So we can just force reinstall one of the packages. So let me open up the commands. So if I want to install Python, let me see. So, right, and it already tells me that the latest version is installed. But if you want to force reinstall it, you can just say ---- force reinstall and then it will do the same thing as it would normally do the first time. So it will download the package, and in this case the version number hasn't changed, so it starts uninstalling it and then it reinstalls the package. So NumPy is relatively easy. So again, we run through all of these different installations. So we run through LlamaChain, which is already satisfied in my case, and we can of course always force reinstall it. So if something goes wrong, just add the force reinstall command so that you reinstall it. All right, so let's go back to PowerPoint. So the first three are just normal packages, so we don't need to do anything. But here, when we do PyTorch, we need to install it with CUDA support, which means that we have to have the CU118 version, which is the CUDA version, and this is the command to do it. So the command is pip install. The force reinstall means that we're going to make sure that even if we have it installed already, we reinstall this version. I'm going to disable the cache directory, so then it will definitely or always download the latest version. And then I use this floaty head kind of thing, right? So the floaty head kind of thing is the way in Windows to have a multi-line command. So this is normally one big line, but then it wouldn't fit on the slide. So you can always kind of continue a command on the next line in Windows by using this hat. And then you need to specify where you want to get the package from. So the package we are going to get from here, and then the package that we're going to install is called Torch. So the official package name is PyTorch, but it's called Torch in the repository. All right, so this will take some time because it will download the PyTorch package and then it will start installing it. So again, if you would run through all of the steps one by one, then it will install PyTorch. So again, if you're on Linux, this is the same command. You just need a different URL, right? So you don't need to have, you don't use this URL because this URL is a URL which is for the Windows package, but you use a different command for the Linux package. All right, so NumPy and PyTorch. So NumPy is for multidimensional arrays. PyTorch is a machine learning framework, so it has all of these different tensors and GPU support. So the next thing is to install the LlamaCPP library. So the LlamaCPP library is the library that we're going to use to load our large language models. It's the interface between this big binary large language model blob and the Python code. And this is done by having a bridge between C++ code, because the original model is loaded using C++ and then Python is used to expose part of the model. So again, in this case, we are doing the same, but we're going to install a very specific version. And this is because, like I said, 4 days ago, the default model was changed, and I wanted to use a GGML model instead of using the new models, which are called GUF, I think. I think it's called a GUF model nowadays. But again, we need to install this, making sure that we use CUDA. So again, we need to first set a certain number of parameters. So we have to set our CMake args. We have to force using CMake, and then we have to install this package, and we're going to install this exact version number. So here you see how to do that. So if you just type the name of the package and then say is and then a version number, it will show you this exact, or it will download and install exactly this version number. So you can very easily switch to older or newer versions of the package. But I'm using 0.1.77, which is like 2.5 weeks old, because of the fact that the default model used is still the GGML model. So the GGML model is the kind of smallest model that I could find, which still has relatively good performance, but it's the one that I use. So again, it's like one big command. If you look on the Firefox, then if we look at the command line, so commands.txt, it's this whole thing, but it's just on a single line in the code. So this is also the last requirement that we need, right? So we need NumPy, LlamaChain, sentence transformers. We don't need simple audio. It's in here because I was doing some audio generation from the large language model. But that is something that we're going to use next week. But this step is one that I didn't mention in the PowerPoint. So for some people, it might be necessary to first upgrade your setup tools before you install PyTorch and before you install LlamaCPP. So this step sometimes needs to be done, sometimes it doesn't. So on my computer it didn't need to be done, but when reading through some of the help files, it actually said sometimes you need to upgrade your setup tools. But I think since I downloaded like a newer version of Python, or almost the latest version of Python, it comes with the correct setup tools. So if anything goes wrong during these two commands, then make sure that you install the setup tools and that you upgrade it using the ---- upgrade. So just to make sure that that works. All right, so then we have everything set up. So this is it. Takes you around 30 minutes. So I've been taking this very slow in the hopes that people can actually, kind of do all of the things, install all of the things at the same time. So I think that should be doable. It's still a big number of downloads and a big install. Like Visual Studio can be a pain in the ass to install. All right, so again, we need to have some additional packages, which we already mentioned, but just a special shout out, because I think that all of these people working on this field, they don't really get enough attention, right? Because there's literally thousands of people working in this field. Everyone writes their own little packages, and in the end people say, well, I use the Llama 2 model, which is developed by Facebook. But of course there's a lot of hundreds of programmers working in the open source sector, which are involved, which make sure that all of these things work. So a special shout out to the guys from LangChain and Sentence Transformer. So LangChain is a language model framework, and then Sentence Transformer is text and image embeddings. So that it's a way that text and images get transformed into this matrix, and then this matrix is used in the large language model. So again, we've already installed them, or you should have already installed them with the other command here. But I just wanted to mention that there's a lot of people, a lot of programmers involved. So a lot of people just say, oh, we use ChatGPT, or we use Llama 2. And of course, Llama 2 is trained by Facebook, but there's literally hundreds of people working on it to make sure that it works. All right, and then the next step is to pick our large language model. And this is a interesting choice. Like I told you guys, if you just install LlamaCPP, the newest version, currently as of the time of recording, is 0.1.79. And there the default is called a GUFF model. However, I wanted to use a GGML model just because I'm on a laptop and my laptop isn't that powerful. I tried switching to the GUFF model yesterday. The GUFF model literally fried my hardware almost. So it's a much better model. It's a different binary representation of more or less the same model, but it's 2 gigabytes bigger, which means that it blows up my memory completely. The laptop starts swapping and the thing just becomes really, really hot, and it doesn't do anything interesting. So the GGML model is 3.5 gigs if you download it, and that is a model that my laptop can handle relatively easily. So when you are picking your large language model, you can literally find, if you go here, this is the one that we're using, but huggingface.co is kind of the website where I kind of learned all of this stuff. So they have really good guides on how to set up an LLM and what all of the different things mean. But there are different large language models trained for different purposes. So there's purposes like text generation, which is the one that we're using today. So today we're using the chat model. But there's also models which are trained to help you code. So there's also a Llama 2 billion or 7 Llama 2 7 billion Python GGML, which is then trained for understanding and debugging Python code. There are also translation models. So you also have translation models for translating English into French, or for example, Dutch into Swahili, right? So there's a lot of people involved in training these models, and it depending on the goal that you have to select a certain type of model, right? So if you want to build a plugin for Visual Studio that can help you with code or write documentation for your code, you're not going to use the chat model. You're most likely going to use a Python embedded model or a C++ trained model. So these models have a different input data set of training. So they're not trained on general text, they're trained on Python code, or they're trained on C++ code, or they're trained on translation code or translations from different languages. Then the next choice that you have to make is the parameter size of the model. So currently, if we are looking at Llama models, so Llama 2 models, they come in 3 different flavors. So you have the 7 billion, 13 billion, and 70 billion model, and this is the number of kind of neurons in the model, right? Because a model is nothing more than a kind of a neural network, and how many neurons you put in this neural network determines how accurately the model is. So the 7 billion one is the least accurate, so to speak. The 13 billion is kind of the medium accurate one, and the 70 billion is the most accurate one that is there. The main problem is that depending on the size of the model, you need a bigger video card, you need more memory to run it. So my laptop can run the 7 billion model. My computer at work, which is a relatively new kind of i9 machine with a relatively good video card, can run the 13 billion model. But running the 70 billion model means that you have to have dedicated hardware for it. So then you are probably going to have to buy one of these latest NVIDIA chips that has like a massive amount of memory so that you can run the 70 billion model. But the text generation, so the quality of the text, is much better when using the 70 billion model compared to the 7 billion model. And then one of the other things that you have to take into account is the context size. So the context size of the model is how much tokens the model can handle in a single call. So let's say that I want to have my model summarize the whole Bible, right? So the whole Bible is a 5 megabyte piece text when I download it in plain text. So a model which has a context size of 2K, so 2000 tokens, is not going to be able to read this whole 5 MB file. Right, so the size of the context is the amount of text that you can give to the model plus the amount of text that the model generates back to you. Right, so a 2K context size model is a model which is limited to having an input plus output of 2000 tokens. A 32K model is a model which is able to do 32,000 input tokens plus output tokens. So this is kind of the limitation of the network. So if you want to have a model which is able to summarize like very, very large pieces of text, then you have to have a model which is trained on a relatively large context size, like a 32K context size model. So in this case, we use the Hugging Face, the 7.2 billion chat. So let me show you where to download that. Right, so the bloke is a guy, again, that trains these models or transforms these models. And you can see that if you scroll down, then it's the Llama 2 7 billion chat GGML model. So this is the type of model. This is the number of parameters, and this is the name of the model. And it is it is developed by Meta, so the company behind Facebook. So you can see here that you have repositories available. So here you can select the second one. So the second one is the 2, 3, 4, 5, 6, and 8-bit GGML models for CPU plus GPU inference. So we click there, and then we end up here. So we scroll down, and then we see all of the different downloads. Right, so the model that we are using is this one, the original quant method, 4 bits. So I downloaded this one. So it is around 3.8 gigs, but you can see that it uses like 6.2 gigabyte of memory on your CPU when you run it. So of course, if you look at the 13 billion or you look at the 70 billion models, then the model download is around 10 times. So you're downloading 30 gigs on your hard drive, and you need around 60 gigabytes of random access memory on your CPU to run it. All right, so how do we download this thing? Well, we can go here, files and versions, and then we see here the different types of models. So I am using this version 4.0. Let me actually check that quite quickly, because I do think that that's the one that I'm using. Yeah, 4.0. So this file, you can just click the download link, and then you have to download 3.6 gigs to your hard drive. So that is the binary representation. So if you think about a model as having an input, a hidden layer, and then an output, then this is the hidden layer of the model. So very big, chunky download. And put it somewhere where you know that you can find it. So in my case, I put mine on the C drive, so I just put it in C/, I made a new folder called LLM and just put the model in there. So it's a big, big file. All right. Now it's time to start coding. So talked a lot already about all of the different things that you need. It took around 40 minutes talking about large language models, but now we can finally start coding and do some stuff into our model. So load in the model, start generating text, start making our Snoop Dogg-inator. But the first thing that we need to do is open Notepad++. So people by now should know that I'm a big fan of Notepad++. Notepad++ looks like this when you open it up, so it's completely empty. So the first thing that we need to do is to start importing all of these packages that we just installed, right? So we need to import the libraries. So I'm going to import some system libraries like sys, time, torch, and NumPy. So those are the kind of big libraries. And then I'm going to import some more specific things from the different LlamaCPP repository, right? So because we installed LlamaCPP, so that is those are all kinds of things to deal with large linear models, large language models. So this is the code that we're going to use. And again, if you're lazy, right, you don't have to type it all in. You can just go to the repository, and in my repository, you see a file which is called main.py, and here you see all of the code, right? So you can just copy paste it from here. But I wanted to show you guys how I developed the code. So I want to go more or less step by step. So for that, I'm going to go to Notepad, and I'm going to just first copy paste in all of these requirements, right? Because I'm lazy as well, so I don't want to type every one. But this is kind of the basic, right? So we need to import all of these different things, and then I'm just going to save this. I'm going to save this in, and I'm going to call this stream.py. So instead of calling it main.py, which is actually the name of the file that we already had, I'm just going to call it stream.py. All right, so this is our basis. So our basis is here. Do you have any link to get some info on modeling DNA by language models? There's no links like that in the presentation, but I can put it in next time because there's different ways that people do it. And one of the ways is CUDA good and the other one is bad. So some people retrain a whole network, which is good, and other people just use prompts. So they prompt engineer kind of a standard language model, which is trained on English language to understand DNA. But there are some pretty good papers out there, some new papers that I saw, where they take a large language model and then they train it using either protein or DNA language. What is the last package that we need to install? All right, so very good. Let's take a step back. So the last package that we install is the LlamaCPP package, and then this specific version. So if we look at the, let me show you the code, right? So instead of going to the code itself, I just go to commands.txt, and then here, this is the order in which I installed them. So first install NumPy LangChain sentence transformer, and then install setup tools by upgrading it. Shouldn't have to, but might. And then we install Torch, and then the last one that we do is this massive command, which actually goes on, but this installs the LlamaCPP Python library. And this one needs to be at version 0.1.77 to have support for the GGML model. So it's just taking this whole, and I can actually show you guys, right? Like, why not? So I just go to here, right? I just reinstalled one. But here, when I do enter, right? So this is the command. It starts downloading the package, and then it starts like compiling everything. And it actually starts compiling like Ninja, CMake, Wheels, setup tools, and all of these things. But you can see that it just downloads more packages, and then it starts compiling it. So this is the compilation step where it uses Visual Studio to compile the CUDA version. So it's kind of a. Let me move this one a little bit. So, see, that looks a little bit better. But this is just the way that Python packages work. So you can see that it throws you all kinds of, and this is all fine. It's still compiling, and it's successfully uninstalled and then reinstalled. And so here you can see that actually this version needs a very specific version of NumPy as well. So it's just a Python requirement. But if everything goes well, then it should look kind of like this, where you see that building CUDA object in the middle, and then linking CUDA object, and then install configuration release, and then that should be all fine, and then installing the project, and then it does a whole bunch of additional install, but that's how it works. I've been able to install. Perfect. So if you're able to install all of the packages, then the next part is going to be easy. So then you have everything that you need. Let me actually open up Notepad for you guys. So the next step is doing, let me go back. So the next step is starting a file, right? So we open up Notepad++ and we just import all of the different libraries. Right, so it looks like this on my slide. So you import sys, time, torch, and numpy. So those are kind of the global system libraries. And then we also say from LangChain, we want to import a certain set of things that we need, right? Because we need a callback manager, we need an LLMchain, we need a Hugging Face embedding, we need a LlamaCPP. So all of these things we want to load from the LangChain library that we installed as well. All right, so this is how it looks. And then next, so I just copy pasted the text, which you can get from the GitHub. But the way that it looks is we need to have our main entry point, right? So in Python, you need to have a main function. So this is going to be our main function. And this is going to call the main function, because we're not going to use anything else. We're just going to have a standalone Python script. So when we call Python, we just want to execute the main, and the main is going to check if CUDA is available, and then it will print to us if CUDA is available, and then it starts a timer. But at this point, we're not going to do anything with the time. We're just going to exit the program. So the first step is taking this little piece of code and then making sure that CUDA is installed correctly, so that both PyTorch as well as the large language Llama 2 model can actually use the GPU. Because if you're not using the GPU, it's going to be bad, because it's going to be really, really slow, and it's going to be really, really annoying, because it will use like 10 cores, burn up your computer, because you really need to do this on GPUs. All right, so a little piece of code, check if CUDA is available. So here we say the device that we want to use is CUDA, if this is true, and else we want to use the CPU, which we kind of don't want to do. And then we just print saying that the device used for our large language model is going to be the device. So we're going to test if CUDA is available, and if it is, this part of the code will now print device used for LLM, CUDA, and if it's not available, it will print device used for large language model, CPU. All right, so let's do that. So let's go to our code and add this little piece. So I can actually just type that because I'm not that lazy. So I'm just going to define a main like this. Then I'm going to do 2 spaces, and then I'm going to say device is equal to, different keyboard layout, CUDA, if torch dot CUDA dot is underscore available, and then else I want to set it, wrong keyboard layout, I want to set it to CPU, right? So the next step is to just print it. So I'm just going to print device used for large language model, and then %s is printing a string, and then I'm going to give this the parameter, so the device, so anything which is in device will be printed at this point. And then that is it. So I'm not going to even bother starting the timer, because we can do that at a later point in time. So the next thing is that if underscore, I'm not allowed to use brackets because it's Python, so it's if underscore underscore name underscore underscore is main, and that also needs to have underscores, underscore underscore main underscore underscore main. So if this is true, then execute the main function. So just a little bit of coding, right? Just to have a very, very basic setup. So the thing that we're going to just do is call into PyTorch, check if CUDA is available, print it out if it is available, yes or no. And we're going to then run the main code, right? So this is just to be able to do Python, and my file is called stream.py. You can name your file anything that you want. So I'm going to go to here, right? So I put it in the right folder. So I'm just going to do Python stream.py, and then it will start loading it, and hopefully everything will work. Fingers crossed. And then it says yes. So the device used for our large language model is going to be CUDA. So, woo. So if this says CPU, something in the previous steps went wrong, right? Either CUDA was not installed correctly, or it came up with an error here in the whole compiling of the LlamaCPP, or something else went wrong, right? So and then in that case, I would advise you to go to the version part of the GitHub, right? So on GitHub, when you go here, you see versions.txt, and then make sure that you have the exact same versions as listed here, because small version mismatches can mean that CUDA is not going to be able to run or anything. So it is a little bit finicky to get the whole environment set up. As soon as you have the environment set up, don't change it, because it will break. And that's the problem, is that it's such a fast developing field that every like 4 to 8 days, some of the packages will get updated, and then code that used to work doesn't work anymore. But that's just because it's a very hip and popular field. All right, so let's go back to our code. So this is our basic code. I hope this is readable. It looks a little bit small on my screen, so I'm going to zoom in a little bit. Right, so very basic code. I am going to add the last part of the PowerPoint presentation. So I am going to start a little timer to show you guys, well, not to show you guys, but to make sure that we time stuff. Right, because I want to know how long stuff takes. How long does it take to load the large language model? When we do a query, how long does it take for the query to end? So that's why I'm having the start equals time.time, just to make sure that we know when we, or how long things take, right? So time.time. So this is just our time. All right. So I hope people were able to do that. It's like just a couple of lines of code. You do need to have all of the imports. So if you have all of the imports done, then it's a like 4-line main or 3-line main code. And it's just calling this main function at the end of the file so that we can just do python main.py or python stream.py or whatever you want to call your file. Right, so just save it with any name that you want. I could have called it snoopdog.py because we're building a Snoop Dogg ennator to translate text into Snoop Dogg. Can you go back to the terminal for a second, please? I missed the last step. All right, so to the terminal, sure. So in the terminal, right, we just say python stream.py or whatever file name you took. Right, so we of course have to go to the folder where you are, right? So you have to go cd c:/GitHub because I'm working in a GitHub folder, and then my folder is called LLM stream, right? So I'm just going to go where I already was. But if you are developing your code, for example, on your desktop, then you have to go cd c:/users/Denny/desktop, something like that. Let me just go there. And then, is it not called desktop? Documents. Should be a desktop folder somewhere. Yeah, that's probably has to do with OneDrive or something. But depending on where you put your files, so I always use my files in C GitHub. So all of the code that I do goes into a separate folder underneath kind of my main GitHub repository folder. So that looks, can I show you guys this? I probably can. Let me close most of the windows. So let me just show my screen and disable that and disable that. So if I look, then it is called, so this is how my C drive looks like, and then I have my GitHub folder somewhere here, and then here I have all of the different projects that I'm working on, and in this case we are working in LLM stream, and then here you have the files. So here's my stream.py, and here's the main.py, which is the one on the GitHub. All right, does that clear anything up? Let me get back all of my windows. Hey Manuel, welcome to the stream. So I hope that helped. So let's go quickly back to here. Right, so depending on where you are, you have to move to where you are. So in this case, I have to go cd c:/GitHub/large language model stream, because that is where I put my code. And now if I type there, then I can see all of the different files. And in this case, we're working with stream.py, so I can just say python stream.py. And when I say python stream.py, it will load all of the libraries. It will check if CUDA support is available. And in this case, yes, CUDA is available. So the setup worked. All right. So I hope that is clear. So this is the minimal kind of setup, right? So we now have libraries loaded. We have the libraries installed, we have set up CUDA, we have set up our environment, and now we are going to have to start with the large language models. So the next step that we need to do is I actually had a slide for this. So the next step is opening up your command prompt like we did before, going to where you saved your file. So in my case, c:/GitHub LLM stream. And then you have to do Python main.py or Python stream.py or whatever you call the main file. And then it will look something like this. So there is a cd call to move from your main folder where you start the command prompt to where you stored your file. All right, so now we start getting into the nitty-gritty, right? So the first thing that we need if we want to use a large language model is we need an embedding. So what is an embedding, you might ask? Well, according to the definition of what an embedding is something that maps text to a 384 dimensional dense vector space. So it is just something you need and no one exactly knows what it is. Well, that's not entirely true, because when you have text, right, so text consists of characters, but a large language model doesn't deal with characters, it deals with tokens. So a token is a part of a word. You can think about it like a, what is it called in English? It's just part of a word, right? So it's, for example, if you chop up a word like demonetize, right? Then it's money, ties, right? So it's kind of 3 tokens. And if you squeeze these 3 tokens into one, right? So in English, a lot of words are kind of composite words, right? Think about bicycle, right? So bi is 2, cycle is kind of wheel, so it's a 2-wheeler, right? You can have a tricycle as well, or a quadcycle, or whatever you want to call it, right? So, but words in themselves are composed of things which are called tokens. And the way that you define these tokens is dependent on the input of your large language model. So Llama 2 uses 384 input tokens. So it looked at all text in the world and then determined that if you use 384 tokens, then you can kind of represent all of the text which is out there. So what we have to do if we take an input text as a prompt, right? So our prompt or our question towards the large language model needs to be mapped into tokens. And this is what an embedding does. So it takes our text and then maps it towards this 384 dimensional dense vector space, which is kind of the translation from words to individual tokens. Right, so a word like demonetization will probably be mapped to 3 tokens, while a word like I is probably going to be just 1 token. A word like we or they or them, those will all be kind of individual tokens, right? So it's just a way of mapping text into the input language. All right, so we put this in our main function, right? So from now on, this is the text we already have in our script file. This was already there as well. So we're just going to add 2 lines of code. So we're going to print loading embedding, and then we're going to define a new variable called embedding. We're going to use the Hugging Face embeddings. The model that we're going to use is called all mini LM L6 v2, which is kind of the default model for this. But we are going to specify some arguments to the model, and the argument is going to be that we want to run the embeddings on the device that we just selected, right? So if everything went well, device should be CUDA, so it should run on your video card. So we're going to use the video card to map from text into the input of the large language model. So let's do this. So let's go here, right? So what are we going to do? Where's my window? That's my window. All right. So I'm just going to say print loading embeddings And then I'm just going to be lazy and I'm just going to copy paste this out because of the fact that I have to otherwise type it in. All right, so let's load the embedding like this. And then let's go back to Notepad, go back to the command prompt, right? And we're just gonna run it again to make sure that it works, right? So it says loading embedding. So you can see that this takes some time, right? Because it needs to transfer the embeddings to the video card and then it quits the program. So in theory, this should be okay. If we want to make sure that everything worked, then of course we can actually print the embedding itself. So we can actually so what I did is I just took the print statement, right? So I can just say print embedding, and then instead of embedding, I'm just doing %s, and then I'm going to say print the textual representation of the embedding variable to the screen. I hope this is readable. So if we go back to the command prompt and we run it again, now it will say loading embeddings, and then what is the training data set for the model? So here you can see now, so the training data set that we are using, and you came in a little bit later, Manuel, we're using the chat Llama model. So the Llama model, so we are using the Llama 2 model, which is the Facebook model, 7 billion node parameters, and this one is trained on chat. So this is the one that contains like Harry Potter books, everything on Reddit, stuff on Twitter. So it's just a general English based data set. So it's not the one used for translation, and it's not the one used for Python coding. And we're using the smallest one, so we're using the 7 billion parameter size model today, because otherwise my laptop will have a heart attack. And I'm not even sure that the stream will hold. As soon as we start doing real video card stuff, it might be that the stream cuts out. Can we train with our own dataset? Yes, you can, but not today, because today we're just going to do fun stuff and we're going to use pre-trained models. I actually want to talk to you guys about next time that we do a stream, because I have some suggestions of stuff that we can do. And I want to know what you guys think is most interesting to you. Because one of the thoughts would be is to take the current Nature paper that was out like 2 weeks ago, where they trained a large language model based on protein, or kind of the triplets. So they train it based on protein sequences and RNA sequences. So it kind of learns about splicing, and it learns about like protein structure. So you can use a large language model to predict if a certain protein code in amino acids will have like a certain structure. So it's like, is it an alpha helix? Is it a beta sheet? So that's something that we can do. One of the other things that I thought about is it might be nice to change your own speech model, which is a little bit easier to do, but a lot more fun, because having the computer speak in your own voice to you is really, really freaky. So I did that at work, and it's just insane, like how good it is. So you can train it with your own data set. You do need, for large language models, you need a massive input data set. So you probably need a hard drive full of text. Just having the Bible is not going to cut it. But the nice thing about speech data sets is that you can just take a pre-trained network and then retrain it using your voice, which is relatively quick, relatively easy to do, and it's just super fun. All right, back to coding, right? So back to coding. So our embedding, right? We put our embedding up. So if I just print out the embedding, so I added this additional thing saying loading, and then I'm printing the value of the embedding variable as a string. The way that it looks something like this. So it says that you loaded a sentence transformer. The max sequence length is 256. It doesn't transform to lowercase. It has 384 word embedding dimensions and all of these other parameters. And most importantly, it was loaded onto the video card. So that is because we want to have stuff that is relatively quick. All right, so that is our embedding. So it should be all fine. Let me make sure that I delete this from the line. Otherwise, we're going to deviate already from the PowerPoint, and I don't really want that. So the next step is going to be writing a little callback handler. So the little callback handler is something that we need, right? We need a way to interact with the large language model. So a callback manager is a little class, so that's why it says class here. And this class inherits from the base callback handler. So everything is implemented as a NOP. So it doesn't do anything, but we can override certain functions, right? So we can have a function which is, for example, init. So this means that as soon as the large language model is initialized, this code is executed by our handler. And then we have another function here, which is on LLM new token. So as soon as the large language model generates a new token, I want to do something. So I want to take that token and add it to a certain token string. Right, so it's our way to interact with the large language model. There are many, many different functions that you can implement. So it's not just on new token. You have things like on chain start, on chain end, on prompt start, on prompt end. But for our current thing that we're building, the Snoop Dogginator, it's actually as easy as just hooking in to when it starts and hooking in to when a new token is generated. Right, so here we actually pass back in our device, right? Because we need to make sure that we're always using the same device. We can't have half of the model run on the GPU and half of the model run on the CPU. So in this case, we are just saying that, well, we have an init function. So when the LLM starts, I want to pass in the device parameter and I want to make a new empty token string. Right, so a class is nothing more than kind of a barrel or different barrels where you can put things in. So here we have two things that we put in. John Cardina, great to see you back, Doctor. Thank you. Great to be back. Great to be streaming again. It's been a while, and I actually miss it a lot. It's just that I've been so busy that I forgot, or not so much forgot about you guys, but it just takes a long time preparing these things and then doing them. And I've been playing a lot of Dwarf Fortress recently, so that takes up a lot of time as well. Had a concert, all the other things. So, you know, life gets in the way, but it's good to be back. So, why don't you want to use Google Colab or something? Because I am an old school programmer and I like doing stuff on my own machine, and I don't like having to pay for other people's computers that I have to use. So doing stuff on like Amazon or Google Collaborative or Latch Bio or some of the other, like there's so many of like these cloud companies now that allow you to do stuff. But I like running stuff on my own computer and being fully in control, right? And that's one of the nice things here. Once you've set up this whole large language model locally, you don't have to have access to the internet. You can actually use it like ChatGPT while you're on an airplane, right? And if you would set it up on Google Colab, you're not going to be able to use it on an airplane. It's good to go to concerts or game some more. Well, there is a limit to the amount of gaming. I do agree with the concerts. Concerts are always really nice to do, but gaming should be illegal at some point. Like I've had days where I've like started Saturday morning at like 8 in the morning and then finish gaming at like 10 in the evening. So that's not healthy. There should be a limit on the amount of gaming that you can do per day. Anyway, let's get back to the large language models. Otherwise, we'll be here for another couple of hours. So, so the callback manager is our way to interact with the large language model. And the way that it works is that every time that the model gets started, the init is called. Every time that a new token is generated by the model, this function on LMM new token is generated. So we can actually put in here what we want, right? What concert is, I actually went to a festival. So I went to the Reading Festival, which is near London. It's a 3-day festival. I just went for the last day. Was a gift by my brother for my birthday, like last year. So initially I was going to go to Ozzy Osbourne. Unfortunately, Ozzy Osbourne cancelled his last tour, so we got rebooked to the Reading Festival, which was really good, really good. Like nice new bands. Saw a lot of good new bands. Also some bad new bands, but mostly good. Actually saw a pretty good German band. Cool. So, but this is our class, our handler, right? So, and the only thing that we do is we just start our handler with the device, and I'm gonna call this LLM, large language model output, right? So it's the class. The class contains two things: a token string, so those are all of the tokens generated by the model, and it contains the device, and the device is either going to be CUDA or it's going to be CPU, based on if we run it. All right, so again, let's add this code. So I always do this step by step. So when I'm developing stuff, I just do 2 lines of code, and in this case a little bit more because I have to define the class. But then I just add it and I just run the code again to see if it still works, to see if it actually does what I expect it to do. So let's go and add this to our code. So I'm just going to copy the class, right? Because it's a relatively large amount of code. Well, not so much, but let's just add it. So I'm adding this on top of the main. Right, so because it's a class and I need it in the main, so I want to have it first. And then I'm just going to start it. So I'm just going to say print loading our handler or something like that. And then I'm going to say LLM out handler. I'm going to say give it the device. Right, so the device is the thing that we defined here, right, at line 1. And then I'm going to call this LLM out, just so that it works. All right, so next step, right? So we have our check for CUDA, we have our embeddings, and then we have our output handler. All right, so let's go see if it works. You guys have to show it that. Right, so we just run, so it says device, CUDA, loading the embeddings, loading our handler. We don't see any errors, so we assume everything went perfectly fine. All right, very cool, very cool. All right, so now we start getting into the nitty-gritty, right? Because now we have more or less everything set up for starting the large language model. Because we have our output handler, we have a way to convert our input into the LLM, right? So we have our embedding to convert text to what it understands. We have our output handler to catch every token that it generates. So now we're going to load our LLM. So the only thing that we have here is this is all very standard, right? So this is the model that I downloaded, this Llama 2 model, 7 billion. It's a GGML version 3, and it's quantized with 4 bits. And this is where I stored it. You probably stored it either in your downloads folder or somewhere else, but you just have to give it the path to the model. And then you have to set all of these parameters. So all of these parameters can be tweaked. So the NCTX, this is the size of the context. So I'm taking the largest size. So the Llama 2 model has a context size of 2K, so I'm saying use the whole 2K. I'm going to spend 100 GPU layers. And I might lower this a little bit since I'm streaming, because I might not be able to run 100 layers on the GPU. But this number you want to set on your own computer as high as possible, because this is the amount of work that's get offloaded from the CPU to the GPU to do the computation there. Number of batches, 512, very default. Number of threads, I set it to 1. So in case you didn't get CUDA to work, you want to set your number of threads as high as possible. You want to use like 10 cores of your CPU, or you want to use like 8 out of 8 cores. But I'm going to set it to 1. And the reason why I'm setting it to 1 is because I'm streaming. So if I would use like 4 or 5 cores and I would use my GPU, right, then stuff would go horribly wrong and the stream would cut out, and that would be the end of the stream. Top K is 10,000, so it will return 10,000 possible next words, so to speak. The temperature is a way of kind of influencing the network, so setting high temperatures or low temperatures will change the responses a little bit. The max tokens is the amount of tokens that it's allowed to generate. So I'm saying maximally generate 2,000 tokens back to me. And then here I specify my callback manager. And I'm actually going to say if verbose is false, because otherwise it will just throw out a whole bunch of information about speed and other things. I assume you have to have an NVIDIA GPU. Yes and no. So if you want to use CUDA, then yes, you need to use an NVIDIA GPU. However, LlamaCPP, this thing here, also supports the GPU that is used in Mac EOS. So it can use Metal, but it can also use AMD GPUs. So, but then you're not compiling CUDA. Then you have to compile the AMD specific version. Let me quickly look that up for you, actually. All right, let me see. LlamaCPP Python. So let me show you Firefox. Not this one here. So you can actually use the open basic linear algebra system as well. So this is a CPU way of doing it, but it's much faster than just using standard CPU. cuBLAS is basic linear algebra for CUDA, right? So this is CUDA, this is NVIDIA specific. CLBLAST is for, I don't know, you can use Metal, which is for EOS. And then you have HipBLAST and RockM, which is for AMD cards, right? So it's just the LlamaCPP command that you change. So you just have to specify which basic linear algebra system you want to use. And depending on which one you choose, it either runs on the CPU, or it runs on NVIDIA cards, or it runs on AMD cards. Well, yeah, that it's true that they are a little bit different, AMD, in the way that they do it. But like you see, there is an AMD specific library for loading machine learning machine learning stuff. I'm actually a little bit surprised that there is no kind of generic Vulkan interface that is using this. Because then it would be vendor agnostic, and you could also do it on Intel cards, because currently like integrated Intel graphic cards are not supported at all, while if you look at the shaders that they support, they do support the shaders that you need for AI and machine learning. So I was actually hoping that someone would actually, instead of having a Metal layer, to have a Vulkan layer. So just have the whole kind of GPU kernel written in Vulkan or in Vulkan shader language, so that it can just use any video card underlying it. But that's probably something that people will do in the future. All right, so back to setting it up. So when we have all of our packages installed, this is the call to create our LLM. So the main thing here is we have to provide our callback manager. So now when every time that the LLM is going to generate a new token, we are receiving the token in our own class. Yeah, NVIDIA is quite good at cornering the market in these kinds of things. So I do agree that NVIDIA is really smart in marketing, and the fact that it's called, like, instead of calling it video card chips, they now called AI chips, right? So it's NVIDIA AI chips. It's quite smart the way that they kind of do that. And they needed it, right? With the whole crash of cryptocurrency. They needed some way to keep their video cards like relevant, and AI is a way of doing that. Although I don't agree with like AI in many cases because it's relatively wasteful. Anyway, so let's add this piece of code, right? So I think I explained all of them. So the model path is where you saved your model. And then these are the parameters that we're going to give it. You can play with the parameters. If you have a better video card, feel free to up the number of GPU layers. If you're like me and you're on a laptop and your card is not that good, scale the layers a little bit back. It will tell you if it can't offload that many, but it's just something that you have to kind of tweak to your system. So depending on your video card, your RAM, and these kinds of things, right? You might have a perfect computer. You might be able to run the 70 billion model. But I have a laptop. I can only run the 7 billion model while doing the stream. So that's what we're doing. All right, so I'm going to go to Notepad. I'm going to add this little piece of code. So I'm not going to type it in because it's a lot of typing. So I'm just going to paste it in. I'm just going to add it here. So, right, so just to check. So this is my path where I'm going to load the model from. This is the callback manager. These are all of them. And then it's fine. And then I'm going to just execute this just to see and check that everything works. Because it should show me at least that it loaded the model, that it's using CUDA. All right, perfectly fine. So you can see here that indeed it found one of the CUDA devices when it started the model, and it's a GeForce. This is my video card. These are my compute capabilities, and then this is all of the parameters that are set by default. And for some reason it hangs there. So I have to press enter a couple of times. So it takes like 25 seconds to set up the whole thing. So to take the model from the hard drive, load it to the video card. Again, you can see here that it's offloading just 35 layers to the GPU. So even though I specified 100 layers, my CPU is only able to offload 35 of them. That's the way. And it actually uses this amount of video RAM for the scratch buffer, and it uses this amount of memory on the video card for each of the states. But it tells me very clearly here that it's using CUDA for GPU acceleration. So at least that's really good. All right, so if you got this to work, then congratulations. You are now an AI machine learning genius because you are able to set up a local large language model and get it to run under Windows, which like a year ago would have been completely insane. Like no one was able to do that. But using all of these new tools, it actually starts becoming relatively easy to do this. All right, but at this point, you can call yourself like an AI wizard or something like that. Another question. I think they just managed to get ahead and everyone started developing their stuff for CUDA. AMD is getting there, but AMD is just, I like their video cards a lot, but they are lagging behind when it comes to driver support, but also support when you think about like new stuff like Vulkan. It took a while for AMD to get on board with that. The thing that I don't like about NVIDIA is that it's all closed source. So you have to use their binary blobs and you just have to run it, and you have to just trust that they're not stealing your credit card info. While for AMD, most of the stuff it's a lot more, AMD is a lot more geared towards the open source community. So as an open source enthusiast, I would definitely go for AMD. It's just that my video card has I just have a NVIDIA in there, so I have to deal with that. All right, so almost there. So now we can start doing the fun stuff, right? So the fun stuff is going to be writing your prompts. And the prompts are the stuff that is going to allow you to rerun or kind of have multiple questions of the same kind of type. Right, so generally when you start doing AI, you build up a prompt library, right? So you might have a prompt that says, summarize this, or you might have so I was actually, the way that I was using it is to have a prompt which answers questions based on specific information that you supply to it. But in this case, our template is going to be very basic. It's going to be a very basic template saying summarize the following text, respond as Snoop Dogg, right? It's going to be a Snoop Dogginator. So the text here is between these curly brackets, and it matches the input variable here, right? So when you run the program later on, you will have to input some text, and the text goes into this part. But it doesn't have to have just one. You can have as many input variables as you want, right? So you can have a template saying, you are name and you are this old, what is your superpower, right? And then based on the name and the age, it will generate a superpower for you or do some other things. So you can be as crazy as you want with your prompts. But there is a really good, like if you want to know more about prompts and chains, look at the docs, right? So every page has a read more, learn more on the bottom. So that is a way of kind of educating yourself, trying to find new stuff to happen. But this is our prompt. So our prompt is just very basically summarize the following text, respond as Snoop Dogg. And what we then do is we take our template, we make it a prompt template, and we tell it that there's an input variable, and this input variable is called text, right? So that means that the user is going to be asked for some text, and then this text is going to be put here between the two floaty air commas. And then we take our prompt and we then make a chain out of it, right? So we give the prompt to the large language model, and in this case we don't want to do anything verbose, so we want to kind of take all of the comments that come out of the large language model and bring it back. All right, so let's add this piece of code. Again, we're going to test it at that point to make sure that everything works. So we're going to go to Notepad and we are going to add this. Right, so very basically summarize the following text, make a prompt template, and then make an LLMchain. So the reason why you do this separate is so that you can reuse it, right? So generally you have a whole bunch of templates for prompts or different prompts that you do. So you might have prompts for summarizing, translating, minimizing, expanding, whatever you want to do with text. I actually saw a very cool research article where they used different templates for simulating different NPCs. So they just had not one large language model, but they had like 6 different large language models. And each one of them had their own kind of info sheet, right? So you are player 1. This is your kind of constitution, your strength, your intelligence, and then it used that kind of character sheet to generate actions for that character. And then these actions were then kind of transport it. So it was really fun. It was kind of like having a little city of large language models all interacting with each other. But that's how you do it. You do it with different prompts. So a prompt is what you want the model to do, and you can reuse it. And this is where kind of the computational efficiency comes in. Right, just starting up the large language model takes you 25 seconds, but then you can do this in a while loop, so you can have different prompts or you can have different inputs in a while loop, so that computationally it's still very, very efficient. All right, so let's run it. I think I saved it. Yeah, I seem to have saved it. So let's run it, and it won't do anything, right? It will print the same thing. It will just make sure that we have the code ready. So in this case, setup took 5 seconds, so that's really, really fast. And we enter, we say no error, so that means that everything went well. All right, so prompts are a way to customize what you want your large language model to do. Prompts have input variables, so that is where you as the user input text into the model. And then a chain is combining a large language model with a certain prompt, and then you can use the chain to run, and you can have multiple chains. You could have like chains that are like 10 or 11 prompts long, but that's the way that you code a large language model. All right, so now the next step is to ask for some input from the user and then run the chain using that, and then print the response and then print how long it took. And then our Snoop Dogginator is done. So last piece of code, very basically we just ask for some input. So we say text equals input a query or something like that, right? So enter a text to Snoop Doggify or something like this, right? So this is the input text that the user will see. Then we run our chain, right? So we say chain.run text equals to text. And then we have our response, and I'm just gonna copy that, right? So we're just gonna print the LLM out. So that is our handler, right, that we gave. And then we're just gonna print the token string that was returned. And well, do give it a new line at the end, right? So something like this. And then we want to know how long it took as well. So let's add the time to it. So the response after this many seconds, and then we print the token string. All right, so this should be all. So now if we run the code, it's going to look like this. So it will of course load the embeddings, load the handler, load the large language model, and then we need to enter a text to Snoop Doggify. Fortunately, I took some texts from Wikipedia. So let me see, input.txt. So it is, for example, trigonometry. So this is the text from the Wikipedia page for trigonometry. So it goes, trigonometry is a branch of mathematics concerned with relationship between angles and ratios of length. The field emerged. So it's just kind of the general introduction about trigonometry on Wikipedia. All right, so I hope I'm still streaming because currently my video card is burning up and my memory is burning up as well. I can show you guys how that looks because it is a relatively scary sight. So let's go here, disable those. Right, so you can see currently that my GPU is like 95% used. You can see my memory is like at the limit, and OBS is struggling probably to get the stream going. All right, but we're done. It worked, very good. So this is the Snoop Doggify text. So yo, what's good, my peeps? So I heard about this trigonometry thing, and let me tell you, it's straight fire. Just sunglasses. It's like math for real life applications, you dig? The Greek and Indians back in the day were all about figuring out angles and ratios of length, and they came up with some dope stuff, man. So that's how it works. That's the idea on a large language model. Cool. So there's 3 different input texts. You can write your own text and have it Snoop Doggified as well. So that's the idea. And of course, the next step is to be creative, right? Because the next step, where do you go from here? Well, that's all about what you want the model to do, right? So get creative. Add some super cool prompts, like make some for loops, make some while loops, add functions, just generally make the code better and bigger. One of the things that I did first is to have 2 different large language models that talk to each other and respond to each other. So you have a prompt, for example, saying that you are a teacher at a university and you are talking to a student, while another prompt is you are a student at a university. So that the 2 different language models have 2 different prompts, and they talk to each other to kind of figure out what's going on, which is very fun to see how they do that. Generally, the next step is to allow the large language model to download from the web, right? So to download new information, for example, from PubMed, or download information from NCBI, or wherever you want to get your information. Especially in biology, one of the first things would be is to connect it to PubMed so that it can read abstracts, right? So you put in a query, it uses this query to query PubMed, learn everything there is to know about your text, and then use the abstracts on PubMed to respond to your query. One of the other things that you could do is add conversational memory, right? Because the prompt currently is just the prompt. This is the text, say it as Snoop Dogg. But it doesn't know what text was said before, right? So you can add a prompt, or you can write a prompt saying that this is the stuff that was previously said, this is the current question, right? So, and then it can understand the difference between what was previously said, and can kind of, you can make it so that you can refine questions and stuff, right? So there's a lot of ways to do. So of course, like, you could come up with 100,000 other things, and then of course you want to profit from it. What do you think about Rust in bioinformatics? I never use Rust ever in my whole life. I think it's a fun little language, but unless, like, the only real advantage of using Rust is that it's memory safe, and you can use it to easily write code which is multi-threaded. So memory safety is something that people in bioinformatics do not care about at all. We like speed, and speed comes within safety in a way, right? We don't want any checks on memory bounds. We don't care if a program crashes or not. So Rust is nice when you want to write like web applications and web servers, because then these kinds of things matter. But for bioinformatics, the only thing that matters is speed. So C is good enough. It has open pointers. It doesn't have a GC, so but it will have its place. Like any language can be used for bioinformatics. So yeah, from this point on, you have your LLM working. Be as creative as you want to do, right? So you can do anything that you want. You can start up 10 of these. You can add a while loop. You can have them do conversations as Snoop Dogg, as Yoda. You can use the prompt to input known literature, right? So say using the following literature, and then have like sections of literature, answer the question, and then have the question, right? So, and then if the literature comes from PubMed, then the question, and you can actually force it to only use the literature that is cited in the prompt, right? But it's all about prompt building and prompt engineering from now on. All right. So for next time, these are the things that I was planning on adding for a next lecture. So the next lecture will talk a little bit about vector stores, because vector stores are a way to give memory to large language models. So to be able to like download literature. One of the things that I actually wanted to show you guys as well is how to use SpeechT5. So SpeechT5 is kind of a large language model for speech synthesis. People will say that, well, it's not a large language model for speech. It's more like a general adversary network. It's a GAN. So it's slightly different, but it's very similar to large language networks. And SpeechT5 is actually amazing. I've been playing around with it. And just using like 5 or 10 minutes of my voice, you can actually have the computer speak to you in your voice. It is freakishly scary how little training data you need to have it sound like you. And then we need PyAudio to generate text from that. One of the things that I think might be interesting as well is to use the NTRES library from Python, so people can access PubMed and have like the large language model summarize like a large amount of text from PubMed, or answer questions about abstracts in PubMed and these kinds of things. But I'm open to suggestions. So in the course of the next coming weeks, if you have something where you think, oh, I really want to do that, just put a comment on the stream down in the comments, right? And then I can think about including something like that. So one of the things is how to train your own large language model. I think using SpeechT5 I can show you much easier, because training a real large language model literally needs like terabytes of data, while training a speech model, which is very similar in the way that you do it, only requires like a couple of WAVs, so a couple of these WAV or MP3 files, right? So you only need like 5 to 10 minutes of speech to retrain one of these speech networks, compared to literally needing terabytes and terabytes of disk space to train a large language model from scratch. But yeah, if you have any other suggestions, and if you're watching this in the future and you have a suggestion, drop it down in the comments. Thank you for the live stream. And non-video related, have you heard about Arizona State University? No, I don't know anything about Arizona State University distant programs. So it's I would actually not go with online or distance learning programs to begin with. I would be in person. I think that helps a lot more. Even though I'm live streaming educational streams, right? I do think it makes a difference. Yeah, so I can link the Nature paper that I talked about in the comments, because I did find it very interesting as well. I might link it. I might link it on the GitHub repository, because in the comments it gets picked up by YouTube and it might be a little bit iffy. But I'm gonna put it on the GitHub, and I will talk about the community of LLM paper. I will add a link to that paper as well, because I really like that. It's kind of like having Stardew Valley, where every actor or NPC in the little village is a large language model that has its own kind of prompt saying that you are X, you're this old, this is what you want, and this is what you do. And then they interact with each other and they start organizing like birthday parties for each other. So it was really interesting to see kind of this emergent behavior, much different from like the Snoop Dogginator. All right. So that was it for today. well, almost 2 hours. I expect it to be a little bit quicker, but that's fine. Thank you guys so much for being here. Thank you for the questions. And again, if you have any other suggestions, just leave them in the comments below the video and I can think about what we want to do next time. Because I do think it's an interesting new development. Like, not so much the large language models themselves, but the things that you can do with them that make them relatively interesting for biology. But I do have some strong opinions on large language models, but I will keep them for myself for now. But we can talk about that more next time. So again, thank you so much for watching. Thank you guys for subscribing and just generally being supportive of the channel. It's really, really appreciated. And if you have any comments, let me know. And I will see you guys next time. So, ciao. Bye-bye.